sklearn, inspection, decision boundary display. A detailed explanation. sklearn, inspection, decision boundary display is a visualization tool within scikit-learn that helps you understand the decision boundary of a trained classifier model. It provides a graphical representation of how the model separates different classes in your data based on their features. Key features. 1. Visualization. The tool creates a 2D plot that shows the decision boundary along with the data points from your dataset. This allows you to visually assess how well your classifier is performing. 2. Flexibility. It supports various classifiers from sklearn, linear model and sklearn, ensemble, including logistic regression, linear SVC, decision tree classifier, random forest classifier, gradient boosting classifier, and more. 3. Customization. You have control over various aspects of the plot, such as coloring. Customize the colors of the decision boundary and the data points. Contours. Choose the number of contour levels to display. Grid size. Adjust the resolution of the decision boundary grid. Axis labels. Set custom labels for the X and Y axes. Title. Add a descriptive title to the plot. How to use decision boundary display. 1. Import the necessary modules. Python. From sklearn, inspection. Import decision boundary display. From sklearn, datasets. Import make classification. From sklearn, linear model. Import logistic regression. 2. Create and train your model. Python. X, Y make classification features. 2. Random state. 42. Model logistic regression. Model physics. Y. 3. Visualize the decision boundary. Python. Decision boundary display. From estimator. Model. X. Response method. Predict. CMAP Verdes. Alpha 0.5. X label feature 1. Y label feature 2. Show true. Understanding the key values in YAML. The code snippet above uses a few key arguments that control the appearance of a decision boundary display. Let's break down their meanings. Model. This is the trained model you want to visualize. Here, we're using the model object created in step 2. X. The input data used for training the model. Response method. This defines the method used to obtain the response from the model. Common options are predict. Predicts the class labels for the data points. Predict proba predicts the probability of each class for the data points. Decision function returns the decision function output of the model. CMAP. This specifies the color map used to represent the decision boundary and data points. For example, Verdes will create a gradient of green to yellow. Alpha. This controls the transparency of the filled area representing the decision boundary. Values range from 0 fully transparent to 1 fully opaque. X label and Y label. These parameters define the labels for the X and Y axes of the plot. Show. This Boolean value determines whether to show the plot immediately. Setting it to true will directly display the plot. Example. Python. Import matplotlib, pyplot as plt. From sklearn, datasets. Import make classification. From sklearn, ensemble. Import random forest classifier. From sklearn, inspection. Import decision boundary display. Create a dataset. X, Y make classification features 2. Random state 0. Train a random forest model. Model random forest classifier. Random state 0. Model physics. Y. Visualize the decision boundary. Disp decision boundary display. From estimator. Model. X. Response method. Predict. CMAPRDYLBU. Alpha 0.5. X label feature 1. Y label feature 2. Show false. Customize the plot with additional details. PLT. Title Decision Boundary of Random Forest Classifier. PLT. Scatix. 0. X. 1. Psi. Edgecalisk. PLT. Show. Additional notes. The Decision Boundary Display tool is particularly helpful for visualizing models with two features. However, it can also be used for models with more features by visualizing the decision boundary for a pair of features at a time. For more advanced customization options, you can access the underlying matplotlib, pyplot figure and axis objects through the Decision Boundary Display, Figure and Decision Boundary Display, Axes attributes. By leveraging Decision Boundary Display, you can gain deeper insights into your model's performance and understand its decision-making process in a visually intuitive way.